Hi, I'm Dan Martin. I am Kit Chair with Best Robotics. Today I want to talk to you a little bit about the returnables kit, what's inside the kit, how it can be assembled, how it can be utilized, and how it can be cared for. As you open your kit, you'll see that the kit contains several different components that are going to be used throughout the season for the robotics competition. Many different components such as the joystick that you see here. There'll be 4 servos. There's going to be a battery charger with batteries in there. On this other side, you'll see that there is a Cortex controller that has several different inputs into that. There are servo extensions. There are servo horns that are down on this side here. There are mounting screws and mounting hardware that is used with the servos as well. There's a communications cable, a USB A to A communications cable that will be in the kit, and there'll be a couple potentiometers that will be used as well. You'll also find in the kit that there are motors that will be used for propelling the robot. There are a couple small motors and there are a couple large motors that are in there. There are some drive components that utilize pulleys and belts, and you can see that this is one of the belts. Actually, there's 2 different belts. One is a very long extended belt that can be customized for whatever the team's need might be. And then there's another smaller belt that is a continuous belt here that is not supposed to be modified. Also, you'll see in the kit there is a pulley that can be used, a large pulley. And then there's several small pulleys that are used in the kit, as well as bearings and a shoulder bolt that holds all that together. In addition, to power the motors, there is a motor controller that's used to control the speed of the motors that needs to be used, and that is connected to a screw terminal interface. There is a battery that is charged with a battery charger specifically for the 7.2 volt battery that you can see on the far side of the graphic here. On some of the kits that will have a battery adapter, power pole battery adapter that you can see here in this image over on the right hand side. Some of the kits will have that power pole adapter, and other kits may just have a Molex connector that looks similar to the one in this shot here that is connected to the Cortex controller. This is an example of how the system is hooked up with the different components. You can see the motor here hooked up to a screw terminal interface. That is connected to the motor controller on the far right hand side there. Those go into the Cortex controller. Also connected here is the servo that you can see right kind of just to the right of the battery. And the battery is connected, as we spoke about, either with the Molex connector or the power pole connector. And there is what's called a VexNet key, or a USB key, that allows you to have wireless communication between the Cortex controller and the joystick. Here we have a close-up look at the Cortex controller and the joystick. The Cortex controller is here on the left, and as you can see, it's a microcontroller. It has dual ARM Cortex CPUs. It is programmable, and you can communicate. You can have a wireless communication between the Cortex controller and the joystick. The joystick is a very traditional gaming style controller that the kids ought to be very used to. And it has, of course, the joysticks. It has buttons that you can use as inputs, and it has an accelerometer that is built in to provide input as well. This is a close-up of the Cortex controller. You can see here that it has several different inputs. It has analog inputs, digital inputs. There are motor inputs and outputs there, as well as the wireless VexNet or USB key. Here we have 8 analog inputs. There are 12 different digital inputs or outputs. There is a speaker port there, and then there's some lights which indicate the status of the system. Over on the right hand side are where the motors are connected. You have 10 motor or servo ports that are available, as well as a standard serial interface. And again, if you look here, this is a USB key or a VexNet key, and that is used for wireless control, wireless communication actually between the Cortex controller and the joystick. The joystick is a PlayStation type controller, and as you can see here at the couple pictures, you can see what it looks like on the top, and you can also look and see what it looks like from the front of the joystick. It has two XY axis analog joysticks that you can be used for inputs. Has 8 buttons that are on the top, 4 on the right, 4 on the left. Has 4 buttons on the front side, 2 on the front right, 2 on the front left. And it has a plug-in USB, plug-in right here on the back side. It's hard to see right here, but you can plug in the USB A to A cable or a Wi-Fi key for communication with the Cortex controller. There is a programmable interface, which is best is not used, and there's a power switch that is right here on the front of the controller. There are 6 AAA rechargeable batteries that are in the consumables kit. Actually, they're in the returnables kit that are used to power the joystick. And there also is there's a 2-axis accelerometer that's in the front of the joystick that can pick up on the motion of the joystick as well. It's for tilt. Okay, so some of the system features of both the joystick and the Cortex controller are that it has wireless communication capabilities. It has 2 2-wire proportional motor control outputs. We don't use those. Those are in motor ports 1 and 10, so those are really not used. But then there are 8 available 3-wire pulse width modulated servo motor outputs, and those are in ports 2 through 9, and those will be used. There are 12 discrete digital input outputs plus the speaker port. There is wireless or direct USB port for program download from a computer to the Cortex. There's an onboard power switch. There's a built-in resettable fuse in case you get a current overload. It's also powered, both of them can be, well, the Cortex can be powered by a 7.2 volt rechargeable battery, and there's also a 9 volt battery backup for Wi-Fi. If you look at the Cortex controller as a whole, you can see where the analog ports are here, 1 through 8 ports, digital in and out, there's 12 ports there, the speaker out, there is ground. Each one of these ports has a ground, a 5 volt power, and a signal. You can see here in the middle you have the USB for wireless communications, or actually for a cable tethered connection for communication between the Cortex controller and the joystick. And then on the other side we have ports 1 through 10 that you can see here. We don't use 1 and 10, but you can use ports 2 through 9, and those have the 3-wire pulse width modulated ports for servo or motor control. If you look on the back of the Cortex controller, you can see there's a configuration switch. There's a crystal interface port for communications that we don't use. There's the on-off switch over on the right-hand side. There's a main battery port where the 7.2 volt battery will be plugged in, and then there's a battery backup port for Wi-Fi communications. If we look at the power that goes into the Cortex, you can see the black represents ground, amber represents positive 5 volts, the blue is for signal or control, the red is battery power, which would be 7.2 volts, the green is also battery power, and the gray is the negative for battery powered. So if you look on the Cortex here, you can see the different color codings and which ports have what inputs into them. On the Cortex controller, there are internal motor controls on ports 1 and 10, but these are not to be used because in an overload situation, it could burn up the Cortex. So you want to make sure that you use the external motor controllers that are provided in your kit. These will connect through a 3-wire external motor controller and a 2-wire screw terminal cable, and they will connect to ports 2 through 9 on the Cortex under the motor control interface. For power reasons, you want to spread out the motors between ports 2 and 9. There are two power banks that are actually available. The first bank is on ports 2 through 5. The second bank is ports 6 through 9. And so these can carry only a certain amount of current. So what you want to do in order not to burn it up, you want to, if you have two motors connected, you want one motor to be connected in ports 2 through 5, and the other motor you would want to connect in ports 6 through 9, one of those, so that there's not an overload situation. Now, if you have servos in there also, you want to take this into consideration. The tricky part is when you may have all four motors connected. You would want to split the large motors up to where one large motor is in ports 2 through 5, the other motor would be in 6 through 9, and then the small motors could be split also between the two. So for one bank you might have a large and a small motor connected, and then for the other bank you would have a large and a small motor connected. So, and then also on the large motors there is a sheet metal shield that's in place, and that needs to remain in place. When you're connecting the wires from the Cortex controller to the motor, you need to make sure that you do not solder the wires to the terminals, but rather use quick disconnect spade terminals that will easily connect to those terminals on the motor. Polarity is not marked on the motors, either positive or negative. It doesn't really matter. If you connect it and the motor's going the way that you don't want it to, you just reverse connections, and that will allow the motor to spin in the right direction that you want to. So it's basically really based on wiring and the program that determines the motor direction. There are four motors in each of the kits, two large and two small, and these motors can be mounted with mounting hardware that will be in the kits. There are screws, 4 screws for each of these kits that can be used for that. It's very important not to use any longer screws than what's provided in the kit, because they will damage the large motor or the small motor. It doesn't really matter. And if you're using these screws, they need to actually be used with the mounting kit so that the screws don't penetrate too deeply inside the motor. For the connections, there are 3-wire connectors for the motor. You have a motor controller here in the middle. There's a 3-wire pulse width modulated connector, and then that connects also to the screw terminal interface through a 2-wire motor cable. And so this junction right here actually can be secured using wire ties, heat shrink tubing, or some painter's tape to make that connection secure and solid. This is a blow up of that connection, and as you can see here, the cables are colored red and black for each of them. Go ahead and match up the red to red, black to black, and that'll cause the motor to turn in a certain direction. If you want the motor to spin in a different direction, go ahead and just flip those around where the red might be connected to the black. It's not going to hurt the motor at all. It'll just cause the motor to spin a different direction. And so you can see here on the bottom right hand side how that would look once they're connected. Now for the servos are used to actuate an item or an arm or something like that, and the way that they're different from the motors is they have a restriction or a limitation of 120 degrees. From a center point it goes 60 degrees either positive or negative, so there's a total range of motion of 120 degrees. You make the same type of connection with the servos to the motor ports as you would with the motors. They're also connected with the 3-wire pulse width modulated cables, and use motor ports 2 through 9 just as you would with the regular motors. There are servo horns that can be connected to the servos that allow different functions, and these servo horns can be modified as your team may wish. Connecting the servos is done very much like the way that the motors are connected. There is a connection here into the motor ports of the Cortex controller. There is a servo power adapter that's in line here that gets connected, and then there is a 3-wire connection right here from the power adapter to the servo itself. So that's how the servos will be connected to the Cortex controller. There is a special way that the servos need to be mounted. There's a mounting hardware kit that comes with the kits, with your robotics kits. What you'll see here is that there are 4 servos per kit. In order to eliminate damage to the servos, you want to use the mounting hardware that comes with it. That consists of 2 rubber grommets, 4 brass spacers, and 4 mounting screws for each servo. And since there's 4 servos, that means that all of that gets multiplied by 4. There would be a total of 8 grommets, 16 of the spacers, and 16 of the mounting screws. These are very small parts, so it's important to keep these in a place where they don't get lost. They're easily lost. So that'll be provided to you in the kits. This is what it looks like when you get your servo out of the box. It would have no mounting hardware at all. First thing you do is attach the rubber grommets to each side, insert the brass spacers, and then secure the servo to wherever you want to mount it with the screws that are provided. Now there's different connections here. These are the digital input connectors, and they're used for limit switches, micro switches, any type of digital input that you might have into your system. You want to connect these to the Cortex using 2-wire sensor screws, terminal cables that you can see here. And those can go into any of the 12 digital inputs. You can see here the connections. You have to program these to do what you want it to, whether it's on or off. You'll have to do that in your programming. 1 would read as open and 2 would read as closed. You can see the sensor cable is keyed where it goes into those digital inputs, which means it has a little slot where it can only go one direction. And so that's just a safety precaution, but you'll see that when you look at the Cortex controller, how that can only go one direction. There are 12 different ports on the Cortex controller that are for digital input-output. Now there's also some analog input connections. These are for the potentiometers. This is where you'd want to connect those. You can connect those to the analog inputs and the sensor cables. For these, because of the way that the kits are delivered, they don't have the 3-wire connectors, and so they have to be configured just a little bit differently to get the potentiometers to work correctly. As you can see in this picture here, we have the potentiometers here. There's 3 different connections that are made to the potentiometer. There's a ground, a 5-volt port, and a signal port. And so in order to get the 2 potentiometers to work correctly, what you want to do is to take those 2-wire cables and actually turn them sideways into ports 1 through 3 on the analog inputs. And the connections are going to be, you'll have to think through the connections a little bit, but all the ones in port 1 would go to 1 potentiometer, with one of them being the ground, one being a 5-volt power, and the other being signal. And then the other potentiometer would probably have the ones that are actually in port 3. Those wires would go to the other potentiometer. So if you have any questions about that, come back to the slide and you can look at that again. But it's a little bit tricky, but it will work just fine. One of the things that you have to do when setting up communications between the joystick and the Cortex controllers, you have to sync the 2 units. So one of the ways that you can do that is to use the USB A to A cable that's provided in the kit. And that will allow you to sync the 2, which actually just makes it so that they're talking to each other. This is how you can sync the 2, is by turning on the Cortex controller, connecting the cable from the Cortex controller to the joystick, and then allowing those 2 to pair or sync. It normally takes about 10 seconds or so for those to sync, and then you'll see the lights, the indicator lights on here indicate that there's a good connection when you look at the VexNet light. When you pull the Cortex controller and the joystick out of the box, this is what you'll see. You'll have, hopefully it'll be synced already and everything will be working just like it needs to. If not, then resync those 2 together. It will have a default program code on the controller that's known as the best default code. That is not the same as the Cortex the VEX next default code. It's separate, it's different, it's from best, and so this is the best default, and that will allow you to actually operate the Cortex with the joystick and your robot through that to allow the motors to do different things and servos to do different default actions without you having to program in that. But this is not the only configuration for the Cortex, and so it's a good place to start, but then after you make sure everything's working, then you need to modify that code to make your robot do what you want it to do. Okay, so it's good for initial checkout, but we want the teams to modify those default codes. Okay, so what you want to look at with the best default code is there is a table here which allows you to know what all the inputs on the joystick do and what they control. So for instance, we have here, if you look at the joystick channel on here on stick 3, which is over on this left-hand side, it indicates that stick 3 will control motor port 2. So if you have a motor plugged into port 2, this channel 3, will control that motor. Likewise, if you have a motor plugged into port 9, channel 3 will also control that. Okay, so stick 3 is the same as channel 3. Stick 4, which is channel 4, is the same left-hand joystick, but it moves left to right, and that would control the motor connected to port 3. And as indicated here, there are different buttons that are both on the top, buttons 7 and 8, as well as 5 and 6 on the front that have different functions. So this is the best default code that is loaded on the Cortex and how it will control your robot. In addition, there are ways to interface with the hardware through programming. And so with the kit, there are 3 basic ways of programming to make a robot do what you want it to do. There is MathWorks Simulink, which actually simulates the way that the robot is programmed, so you can see ahead of time how it's going to behave based on the way that you have it programmed. There's Easy C that's available, which is a little bit easier to get a head start on. If you're starting this for the first time, that's probably a really good choice. For some of the more advanced teams, they might want to use Robot C, which is based on C, but it is it's a text editor. Easy C is drag and drop programming elements, and then Robot C has a little bit more functionality, but is a little bit more difficult to handle at first. So if you have a more advanced team, they might want to use Robot C. One of the first things that you're going to have to do when you get your Cortex and the joystick controller is you're going to need to download a program from the default program. And so one of the ways that you can do that is to use the USB A to A cable that's provided in your kit. This can be directly connected to a computer, and then that default program can be directly downloaded to the Cortex controller. Another way to do that is through some other cabling, going through the joystick into the Cortex. This route method is not used as often, but it's also a possibility. And then there's a wireless connection that you can make between the joystick and the Cortex controller that can be used as well. Now, some of the testing tips that we want to use for the teams when you're trying to test out your system is make sure before you start your robot, when you download the program, it's going to want to start right away. So make sure that your robot is in a safe position when that program is downloaded, because it's going to start right away. You want to make sure that it's not going to be on a table where it can fall off, or you got to make sure that all the team members are out of the way when the program is downloaded. You can either connect the Wi-Fi keys, or you can tether a cable between the two to download the program. Make sure that the Cortex switch is in the off position. And then you attach a charged battery. Charge up your batteries really well before you get started to make sure they're going to provide the power that they need to. Then you'll turn on your joystick. If you're not using a tether, you'll turn the Cortex switch to the on position. And then for the Wi-Fi communication, like it should establish, it takes about 10 seconds for the two units to talk to each other. And then you can test the robot operations with the transmitter. Now there's different status lights that give you an indication of the status of both the joystick and the Cortex controller. The top light will give you an indication of if the battery in the joystick is good. The second light lets you know if the robot battery is in good shape. And then the third light is the communication status between the joystick and the Cortex controller. The last light is a game status, but it's not used by BEST. So there's various indications. Green lights mean good. Yellow lights are a warning saying there's a potential problem or your battery's getting a little weak. And red means that your battery's dead and that you need to recharge it. So these are the status lights that are on the joystick and the Cortex controller. Some other tips for allowing your system to work like it needs to. Again, make sure that when you connect the wires to the motor that you use quick disconnect or spade terminals to do that. It allows for easy connection between the two. Do not solder any wires to the Cortex controller. Any of the sensor cables, servo power adapter cables, and external motor, make sure that they are all keyed in the correct orientation. Normally the ground wire is to the outside of the Cortex controller. You need to insert and remove them carefully so as not to damage any of the connectors. Make sure that you tighten the screws on the motors and the sensor connector cables so there's good electrical connection so it doesn't come loose and you don't lose control of those. Mount the Cortex to the robot using number 8 screws through the holes that are provided on the Cortex. Avoid hot insertion of the USB keys. Make sure the system is powered down before you connect and disconnect the USB keys. And then also, as an alternative to using the wireless communication between the joystick and the Cortex controller, you can use the USB A to A cable for a tethered connection. And realize that the motors and the servos can be destroyed if they are bound, if they're put into a situation where they're improperly constrained. And that leads to gears getting destroyed within those units. So be very careful with them. Make sure you don't put motors in opposition to each other. The joystick may need to be calibrated at some point. If you find that there's a hum or that the motors hum or creep when they're not supposed to, if the sticks are not returning back to the neutral or zero position, then you might want to look at calibrating the joystick. And there's a procedure that's listed here. It's also available on the BEST website under participant resources. So if you find that that's happening, go through the procedure to calibrate the joystick. Now there's resources available online. We certainly didn't cover everything in this little segment, but I wanted to point you to some of the resources. BEST, of course, has many of the participant resources there on its site. There's a message board for anyone that wants to post a message. You can share ideas through that message board. If you have any questions, there's a question and answer segment on the BEST website as well, especially once you get into the competition and you have a question as to whether something is legal or not. That question can be posted and the BEST officials will respond to that so that everybody can see what the answer is, so there's clear communication. In addition, there is information on the VEX forum that's available, and there's a site called Robot Events, BEST forum that you can use as well. And that concludes this presentation. If you need any more information, please contact the online resources that were mentioned previously. Thank you very much.